So we have quadratic function here, and this is DEB Mock 2020, paper 1, question 5. The function is defined as this. So this is the name of the function, x is your inputs, and then y is your outputs. X has to be a real number. So then find the range of values for x for which f of x is greater than 12. Two ways to do this. You could try and graph it perfectly. Now, when you graph it, we should know that it will, have a turning point wherever, and let's just say it has a turning point there. And you'll look for where is your function greater than, let's say 12 is about there. Now you have to graph it perfectly to do that. I'd rather do the algebra way, but like I said, there's at least two ways to do it. So where is my function greater than 12? Well, I'm actually just going to move this around. X squared plus 2x plus 9 minus 12, when I bring this over here, is minus 3, greater than or equal to 0. So where is this above 0? So I could either do where is that above 12 or else where is this above 0? Well, I need to find out what it looks like. So we know it's a U shape. Where does it cut the x-axis and where does it cut the y-axis? I find that by finding the roots. X squared plus 2x minus 3 equals 0. Whatever way you figure them out, find your factors and then find your roots. So x is minus 3 and x is 1. So minus 3 and a 1. And I know it's a U shape. Don't know how high or how low it goes or anything like that. Sorry, how low it goes. But I'm just sketching. And where is your graph above 0? There and there. So that means that anywhere where the x value is below minus 3 or anywhere where the x value is above a 1. Next bit. Find the set of values for k for which my function equaling to k times x has no real roots. So not asking me to solve for the roots. So I don't care about the minus b formula. I don't care about like the doing my factorizing and finding my roots. What I care about is the type of roots. So now I can do a video to go into detail on this if you want, but there is such a thing called the discriminant. It's the b squared minus 4ac. So if you use the full minus b formula, you would find the roots. You'd solve the equation and find the roots. They don't ask you to find the roots. They tell you the type of roots. And this part of the minus b formula discriminates between the types of root. Oh, this is this type of root. This will be this type of root. And what you should hopefully have looked at, but as I said, I can do a full video on this, b squared minus 4ac. If you get the minus b plus or minus the square root of, if what's under here is a 0, if the b squared minus 4ac is a 0, you'll get two real repeated roots. Now why 2? Well, look at my function, it's an x squared. So we're expecting two solutions. Why are they repeated? Well, you get the minus b plus or minus 0. So whatever this number is, plus 0, sure, no, that doesn't make a difference. Whatever that number, minus 0, so that doesn't make a difference. That's how you end up with two repeated real roots. If the b squared minus 4ac is greater than 0, you get two real different roots or distinct roots, whatever word you want to use. And if the b squared minus 4ac is less than 0, you get two complex roots. And we've looked at that. That's where we end up looking at complex numbers. What's under the square root is a minus, maybe minus 9, and we are trying to get the square root of a minus 9. and the calculator won't do that for you. So that's how you end up going into complex roots. So what have they said in the question? Where does this, so my f of x equals kx, have no real roots? Well, here's complex. So here's your complex, or they're usually called non-real roots. So I should have written that down. Actually, this is technically, I should be calling them two non-real roots, not two complex roots, because of the definition of a complex number. So you'll get two non-real roots. How do I use the minus b formula in general? If you go to your log tables, Sky, stop. Every day she wants to say hi on the videos, I think. You go to your log tables, it says if you intend on using the minus b formula or any part of it, you need to have this equal to 0. At the minute, mine's not equal to 0. So x squared plus 2x minus kx plus 9 equals 0. And, you know, it says a is whatever's attached to the x squared, b is whatever's attached to the x, and c is what's left. So what's attached to the x squared? It's a 1. So a is 1. B is whatever is attached to the x. So 2 minus k, or, you know, if you want to take the x out in common, that's fine. But I can just see it there. 2 minus k is what's attached, and c is the 9. So two non-real roots, b squared minus 4ac, less than 0. So that's b squared minus 4 times a times c less than 0. And you need to just work that out. When you work it out, you'll end up with, I think it's k squared minus 4k minus 32 less than or equal to 0. And, you know, this is the same as back up here, solving one of these. So how do I solve a quadratic and show where it's less than 0? Well, I need to sketch it. So get your roots. Again, you get your roots by letting it equal to 0 and working it out. You'll end up with minus 4 and 8. Sketch it. And where is it below 0? Well, anywhere where k is between minus 4 and 8. Next bit. Write f of x in this form. So f of x is all the way back up at the top. And they want me to write it in this form here, which is called completing the square form. It's just a form where you'll notice it. And again, I can do a video on this if you want, but there's your parent function, x squared. If you move it up to, it looks like that. If you move it down 3, it looks like that. If you want to move it 2 to the right, it looks like that. And let's say you want to move it 2 to the right and 1 down. So we can do a whole video on this if you want, but that's the form of it. So if you move this 2 to the right and 1 down, you now have the turning point 2 minus 1. And if you get this, like my function, into this format, you'll be able to pick out the turning point pretty fast. Now you'd be able to do that by differentiation anyway, but okay, so how do we do this? We take this middle number here. So it's a 2 is what the coefficient of the x is. You half it and square it. What happens when I half it? I get 1. What happens when I square it? I get 1. Now, I can't just change the function. I'm not changing it. So what do I need to do there to make them be the same? Well, x squared plus 2x plus 2x plus 1 plus 9. Okay, so I need to add on a plus 8. Take this bit here and factorize it. You'll end up with x plus 1 to be squared plus 8. So now it's in completing the square format. Just in case, if you wanted to, this is saying you got the original function, you moved it to the left 1, and you moved it up 8. So your turning point is now minus 1, 8. They didn't ask me that, but I'm just giving you that little bit of information. Hence, find the largest value of 1 over f of x. I'd start messing around with this. 1 over f of x. I'm sure they asked me to write it in this format for a reason. So, start picturing. If you sub in 10, you get 10 plus 1, 11 squared. 121 plus 8, 129. So 1 over 129. That's not a very large value. 1 over 129 is quite small. Maybe if I go for a smaller. So let's say x is a 1. So 1 plus 1 is 2. 2 squared is 4. Plus 8 is 12. So 1/12. Okay, so that is bigger at least than what I had said there. 1 over 129. 1 over 129 is a tiny piece of a cake or whatever. So 1 over 12 is at least easier bit of a cake, or bigger bit of a cake to get. And eventually, you know, after a little bit of thinking here, you might get to the point of what's a minus 2 plus a 1? Well, that gives me minus 1 squared. Okay, so there's the 12th again. What happens if this was a minus 1? Minus 1 plus a 1 is 0. 0 squared is 0 plus 8. So that's the largest value I can get if this happens to be a minus 1. Seems as though the largest piece of a cake I can get is an 1/8 if this is what I have to work with. And last bit of the question, simultaneous equation. I've never seen one exactly like this before. So good few ways to do it. Normally what I would do is I would try and get rid of the fractions. If you do that, it should work out. I'm going to just stay with the fractions at the minute, and I'm actually even going to write them in order, kind of the x's first and then the y's. So minus 3 over x plus 2 over y equals minus 19 over 4. And what I probably will do here is if I multiply the top by a 3 and the bottom by a 4, I'll end up with the stuff cancelling out here. So I end up with 12 over x plus 9 over y equals minus 15, and a minus 12 over x plus 8 over y equals minus 19. So if you have 8 over y and 9 over y, you have 17 over y is equal to minus 34. Multiply both sides by y and divide by minus 34. And then you can just go back to the start, and if y equals minus a half, what does x equal to? Well, just throw it back into any of them and you'll end up with x is equal to 4. If you've done that a different way, it might have taken you maybe a little bit longer to do out, but it would have turned out exactly the same. When you are happy with all of that and you feel like you understand it, these are the questions I would try from your exam papers. I'm sure there's more than this that you could try if you wanted to, but I picked out 6 questions there that you can have a go at if you want